What's up, guys? This is going to be probably a bit of a lengthy-ish video. I'm going to try and keep it as, brief as possible, but I do tend to take my time with my rambles, as you know. Anyways, this is going to be me explaining why for JOLL and JOLL, there's never really going to be like a PDF that you can learn from or like a tutorial. I mean, there's tutorials that like I've put out, but like it's not going to be like these are the algorithms, this is how you learn it. There's never going to be like a PDF image sheet that you can like print out and put on your wall. With JOLL and JOLL, you really do have to put in the effort yourself, and there's a very good reason for it. At the end of the video, I am going to make a proposition on how we could potentially make better resources for it. However, I need to find a cuber who understands how to code things and, make websites that actually, like generate cube images and stuff like that. I can't really do that. I just mess around with ClickFunnels because I'm a pleb. Anyways, we're going to take this over to our cubes, spin it over this way, and hopefully get the angle right. Okay, so here's just a couple examples of why you're never going to see like a JOLL and JOLL alg sheet, so to speak. Let's take this JOLL for example. For this case, the way I would recognize the JOLL is because these two are the same and these two are opposite. I know that after doing fat F double sexy F prime, fat F prime rather, I'll have to do a U prime to put headlights on left. That doesn't necessarily mean I will do a U prime, I'm just noting that the headlights will be a U prime away from being in the left, which is where most AG corner swap PLLs are, T-perm, F-perm, G-perms, one of the R-perms could be two depending on the alg you use, one of the J-perms could be two. Basically you're most likely to have to put the headlights on the left, which is why I note it that way with JOLL. So you do that, U prime, and then sure enough it is one of the many PLLs where headlights are on left. However, so I'll just do that to this cube and then leave it here. So that's without doing any U moves. As you can see, these two cubes are the same. Headlights are on back. But what if, for whatever reason, just because of personal preference, because every single OLL case does not have a objectively optimal OLL, there is quite a lot of room for personal preference, and there's also room for future development where we discover new algorithms that are actually better than previous ones that we thought. So maybe you actually do U prime and then you do the R prime U prime sledge into finishing the back zone like that. Perfectly valid OLL, but the thing is, because you're using a different alg to what I used before, the ROLL, the role recognition, completely changes because now the headlights end up on the right. And that is basically the fundamental problem to why we can't make JOLL and JOLL resources such that you just print them out and then learn from them, because it really depends on what algorithms you actually use. And yes, there are at least a number of OLLs where we do know for certain what the best alg is. For example, one other thing I'll show is you could also be doing from that angle. So there's technically like 3 very valid OLL solutions for that give completely different ROLL. But there are of course like some OLLs, like this one, if it's not fat F or that, or I guess even a better example would be Fruroff. Like it's not likely that you're going to be doing that as your OLL. There's pretty much only one correct OLL. So for cases like that, yes, you can document JOLL and JOLL in that sort of way. But for the vast majority of OLLs, there isn't really a correct answer, because for this one you could be doing fat F, you're doing R prime U prime, you could be doing F like that. Just give me a sec. Just got some throat problems. Perfect time to film a video when you got throat problems. So that's with JOLL, which is basically the edge equivalent. So we note that these two stickers here are opposite. If we were to use the fat F alg, or the F alg, we know that normally, I'll set up on this cube, since these two edges are normally adjacent colors, so not opposite colors when we do this alg, we know that because these are opposite in this case, and normally this OLL corresponds to them being adjacent, we know that the edges will be adjacently permuted. There is a 0% chance that the edges will be oppositely permuted, so we can rule out, even ignoring ROLL, we can rule out E-perm, A-perms, N-perms, E-perm, T-perm, F-perm, and yeah, so you can rule out all those PLLs just because of that, because we know how the JOLL works for that case. But if we use this alg, where it's r prime, u prime, sledge, that actually does correspond to these two edges being opposite. As you can see here. In this case, they are opposite when you use this alg, and that is what corresponds to them being solved. So because opposite corresponds with opposite, we do know that they will be oppositely permuted. So that rules out everything else that isn't T-perm, F-perm, A-perms, and then in combination with roll, you can also rule out N-perm, E-perm, and H-perm and Z-perm. So you have it narrowed down to 4 PLLs because of that. That's pretty much why roll and JOLL is good, by the way, if you didn't know. It's making PLL prediction a metric shit ton easier with, you know, relatively little information, basically. But the point being, because we use a different alg, there is a completely different JOLL for that case. Another example, this OLL. This is a great example of an OLL where lots of people are going to use different algorithms and there isn't really a correct answer, so to speak. If you do F R prime F, which is what I like, or what I would do if I wasn't doing EO into ZB, that corresponds with headlights ending up on front. But if you do FU, da-da-da, now they end up on left. And again, same as before, I'll set them up again really quick. With JOLL, again, so looking at the edges, the case that goes FR prime F, these two are opposite, like that. Because these are adjacent, and normally it corresponds to opposite, that means that we are definitely getting adjacently permuted edges. For the other alg, say the one that's like this, we have adjacent edges. And because we have adjacent edges, this is probably the worst case of JOLL, because when you see the adjacent and you know it corresponds with adjacent, it doesn't actually rule out anything. It just means it could be either opposite or adjacent. It really does depend. So you could do that and then get F-perm, although G-perms and other PLLs are just as possible. But if we swap these two edges here and these two corners, so like that, they're still adjacent and similar looking case to before. But now instead of having oppositely permuted edges, we have adjacently permuted edges. So yeah, another example of why roll and JOLL, you know, like strict documented printable PDFs and things like that that people like to learn from are not going to exist. You're not going to see roll and JOLL on AlcDB anytime soon because it just doesn't integrate well. And then another example, and this is mostly just to show off an OLL that I really like. Let's take this OLL for example. A lot of people like to do U2, L, F prime, blah blah blah. I don't particularly like that alg. Some people like to do it from the back like that. I find that a little better. Or you could do the RUF thing. Again, I'm not a huge fan of any of those, but they all do work pretty well. Or if you use that, which is like fat F prime, da-da-da, well, suddenly it corresponds to a different, it just affects the pieces differently on the last layer. So like this is how it would look with the PLL skip. Opposite colors here, and then the CP is like this. Whereas if you're using, this alg, similar edges, CP is slightly different, and that just affects the role recognition slightly. JOLL technically doesn't change in this case, but the point is it can change because the best algorithms for OLLs can change, and I think, at least for me, like, just because, you know, like cube advancements, hard magnets, people just getting better at S-slices in general, algorithms like this that were previously not considered particularly viable. I'm not doing a great job of executing at the moment, but you get the idea. Like, algorithms are going to change over time, and as algorithms change, roll and JOLL completely changes. So you get J-perm in that case, as opposed to a Y-perm. Or any of the possible diag PLLs, because again, ADG, corresponding to ADG doesn't give you real good information. So that's pretty much all I wanted to say on why roll and JOLL documentation isn't really going to exist in the traditional sense. But like I alluded to in the beginning of the video, we could have something, and again, it would require someone who knows how to make a proper, cube website where you can generate images and generate, well, cube-specific images, like showing what the corners look like, and just like giving you like information based on like algorithmic inputs. What I think would be best for roll and JOLL is some sort of website where you put in an OLL algorithm, and when you put that in, it tells you what CP case it will be when it corresponds to diag, what it'll be when it corresponds to solved, and then what it'll be when it corresponds to headlights being either in the back, front, left, or right for an ADGE PLL. And then on top of that, it also gives you the JOLL information based on the two unoriented edges, because the way or at least the way I've used and like devised and explained JOLL to people, I use the unoriented edges because they're the easiest ones to see. So based on those edges, it will tell you whether opposite corresponds to ADGE or opposite corresponds to opposite, or if ADGE corresponds to ADGE or if ADGE corresponds to no information. Basically just something where you type in the alg and it gives you all of the like relevant roll and JOLL information that you can then learn. Because that way, if a new algorithm comes into existence, before you try and like learn the algorithm and implement it into your solves, you can actually spend a little bit of time looking at it, like using this roll and JOLL hypothetical website, and you can take, you know, some notes and play around with it for a bit to see how it actually corresponds to certain CP cases and edge cases. So that's pretty much all I've got to say for this video. If anyone wants to help me work on this project, I would mostly just be the ideas man, because I am an absolutely fucking useless computer person. Let me know. And I think that would be cool. And that's pretty much it for this one. I will be making a video explaining JOLL probably in a day or two, because I think it would make sense to have one to go with my roll video. I might also include some like other info about JOLL, like where it could go, as opposed to, you know, how I've documented it thus far. So stay tuned for that. Thanks for watching. See you in the next one.